right, let's go ahead and get started with the last section that we have to look at. And this is data from what we call the Southeast. So, of course, our first step is to just sort that data that they give us in the book from least to greatest. All right, so we have done that. We've gone from raw data to sorted data. Now, we notice that we have 12 points, and our lowest value, our minimum, is 1.8. Our highest value, our maximum, is 18.1. Now, we don't know yet whether that's going to be the edge of our whiskers or not, but we know we have our low and our high values. Now, if we subtract those two, we get maximum minus the minimum, and we have 16.3. That's our range right now. And we can use this data to compute our median. That's always the easiest thing to do, and that's one of our first couple of steps. So we have 12 data points, and that's an even number. So we have to find the two center points. And in this case, the two center points here are 4.3 and 4.6. All right. And if you notice, I number mine. You see that little hashtag up there? I number my data points to help me remember, okay, this is my first one, these are my middle points, so on and so forth. But 4.3 plus 4.6 is 8.9, divided by 2 is 4.45. All right, so now we have a median, 4.45. And now if we look at our lower quartile, we'll notice that we have data points that are less than the median. So let's go and see if we can find all of the data points that are less than the median. And we have 1.8, 2.8, 2.9, 4.2, 4.3, and then another 4.3. We can't use 4.45 because that's our median, and it's not an actual data point. It's just that's our median. All right, that's our dividing line. So looking at this, we have 6 data points, and again, that's an even number. So we take the average of the two center points, 2.9 and 4.2. 2.9 plus 4.2 divided by 2 is 7.1 divided by 2, 3.55. So our lower quartile is 3.55, the median of those low numbers. Now we can look at the upper quartile. And the data points that are greater than 4.45 include 4.6, 6, 7.6, 8.9, 9.4, and 18.1. All right, so again, 6 data points, which means we have an even number. We're going to take those two center points, 7.6 and 8.9. We add them up, we get 16.5 divided by 2 is 8.25. So our upper quartile is 8.25. All right, now we can find our interquartile range. That's the difference between the upper and lower quartiles. So we have the upper quartile, 8.25, minus the lower quartile, 3.55, and that will give us 4.7. That's where that 4.7 comes from. Now, if we find our outliers, we have to figure out, well, what's a reasonable range for that? And the guy who invented it just came up with the number 1.5 as a measurement of how much you need to multiply that interquartile range with. So he said, multiply that 4.7 by 1.5, and that is going to give you a standard for measuring whether a value is way outside the data range or way below the data range. All right, so 4.7 times 1.5 is 7.05. And what that says is our lower quartile, 3.55, minus 7.05 is negative 3.5. So any values below negative 3.5 are low outliers. We don't have any values like that. So our lower edge of our whisker, we can go ahead and use 1.8. Let's see if that's the same case for our outliers on the upper side. So 8.25 is our upper quartile plus 7.05. We get 15.3. So what that says is any values above 15.3 are upper outliers. And it turns out we have one, 18.1. So 18.1 is an outlier, which means that that is what we're going to represent with an asterisk when we make our box plot. And the upper edge of our whisker is actually going to be 9.4. See the blue? We're going to use 9.4 as our upper edge of our whisker. We have all of the material we need now to create the second half of our box plot. So let's keep going. Here we have all of our ingredients. So let's go on to the plot itself. Now, we have the southeast. We're going to move that out of the way for a second. The median here is 4.45. So that's where we start with the southeast. Our lower quartile is 3.55. And we just line our pieces up in the spots that correspond to our number line at the bottom. So I just put that lower quartile right before the 4 because that measurement is 3.55. The upper quartile is 8.25. So I'm going to put that just a little bit in front of the 8, and I'm going to just position it where I've got my other pieces. 8.25. The lower edge of our whisker is 1.8. So see, I just added that piece down here closer to the 0. The upper edge of our whisker is 9.4. So we have added that, and you can see that our upper edge of our whisker is right here at 9.4. And our outlier is 18.1. And that's going to be the value represented by the asterisk because it does not fit with most of the rest of our data points. All right, and we only have one outlier for this one. We could have more than one, but we've only got one outlier for the southeast set of data. So there you have it. That's our double box plot. And it took us all those 5 minutes of math to get to the point where we understand the basis for this. I wanted to give you some of the vocabulary for it and tell you how to build one. I didn't just want to start with this screen and go, hey, there it is. 10 seconds in and I'm done. Here's a world record 5 minutes of math in 10 seconds. I want you guys to actually know where it's coming from. So we have the southeast on top. There's the Box-And-Whisker plot right there on the top. And there's the west. We have a Box-And-Whisker plot down there. And this is actually what we're looking for with question number 1. It's asking us to draw exactly this. All right. So you didn't have to write down everything in the last 3 or 4 videos. What we were looking for was a foundation for this. All right. So going on. Now, this is finally question number 2. The height in inches of girls and boys. And we've got a double box plot again, a double Box-And-Whisker plot. And if you notice, we have, and I moved that title out of the way because I'm going to need that space. Here's the bottom 25% of all the heights measured. So for the boys, the bottom 25 is between 63 and 66 inches. For the girls, it's between 61 and 64 inches. All right. Here's the 26th to 50th percentile of all the heights. For the boys, that's between 66 and 67 inches tall. For the girls, it's between 64 and 65 inches tall. Here's the heights for the 51st through the 75th percentile for all the heights measured. For the boys, it's 67 to 69 inches. For the girls, it's 65 to 67 inches. And the idea behind this, and yes, the 100th percent, the 76th to the 100th percentile is up here at the top. And I didn't talk about that, but I think you guys kind of get the idea. Each of these sections is exactly 25% of all your data. That's why we call them quartiles. Just like you have a quarter be 25% of a dollar, each section is 25% of all your data points. So there we go. That's the top 25% I was just talking about. Apparently I have one of my pictures out of order, but that's all good. So we have 4 sections. Each section includes 25% of all the heights measured. For the girls for this, the top heights, the top 25th percentile is from 67 to 70, and the top 25th percentile is from 69 to 71 inches. All right. Now, there's another way to look at this. Here's 25% of all the data points. Here's 50% of all the data points. Here's 75% of all the data points. And here's 100% of all the data points. So there's a couple of ways you could look at that. Now, last thing, our dividing lines. Here's our lower quartile, the median for the lower halves of all the measured heights. Here's our median heights for both the girls and the boys. And here's our upper quartile, the median for the upper halves of the heights for both boys and girls. All right. And what we find is we have some commonalities. The upper quartile for girls at 67 inches is the same as the median height for the boys. Okay, see how I went back and forth? The upper quartile for the girls is the same as the median height for the boys, and that's 67 inches. And number 2 really asks us to compare and contrast what we see for the girls and the boys. The shortest heights are shown here. The tallest heights are shown here. Those are the edges of our box plot. Now, I said before I was going to explain quartiles, and this is what I meant. I was going to wait to number 2 to explain them because I wanted y'all to see the math first and then see in images what this looks like. So, what should you write down for number 2? Let's take a look. So for the part where we're doing the drawing of the double box plot, that was covered in the last couple of videos. But the southeastern states, for part 1B, the southeastern states have a higher population, a higher median, and different outliers. For part 2A, the boys are taller than the girls. They have a higher median height. The boys and the girls have a point in common, 67 inches. It's the upper quartile for the girls, but it's the median for the boys. And for part 2B, if you look at that graph and remember our rule for quartiles, each section is 25%. 3/4 of the girls, or 75%, are shorter than 67 inches, but only half the boys are shorter than 67 inches. So that's a good starting place for part B. Now, you could probably pull out more comparisons on your own, and I hope you do, but that's kind of what we were looking for those two. So this is an introduction to Box-And-Whiskers, Box-And-Whisker plots. I may also call them box plots. And I hope that this helped. I didn't intend for this particular part to go this long, but if you hung in there, thank you so much. I am proud of you, and I will talk to you soon. Have a good one.